And now in this lecture we'll answer on two questions. In the first question we'll find out the area of this circle, and in the second question we'll find out the area of this trapezoid ABCD. So we'll start with the first question. In the drawing we have a circle, and we have also triangle, the right triangle ACP that cuts the circle at 2 points, point A and this point. You know that this is angle ACB, that is the right angle, and therefore triangle ACB is the right triangle ACP is the right angle. In addition, we know that side CP of this triangle ABC equals to 4 units in its length. This is side BC that is equals to 1 unit. And our mission is to find out the area of this circle. So first of all, we can implement here rule 2. Well, if we focus on this current standpoint, point P, from this current standpoint, point P, we have two tangents to the circle, tangent PA and tangent PB. And according to rule 2, they are equal to each other. That is to say PA equals to PB. So I write it down. According to rule 2, PA equals to PB. But we know that PB equals to 4 plus 1, that is 5. So we write that PB equals to 5. And from this equation, PA equals to PB equals to 5. We derive that PA also equals to 5 units in its length. PA equals to 5. So this is line 7 PA or side PA, that is equals to 5 units in its length. In the next step, I'll copy the right triangle ACP in a new page, and we will implement the Pythagoras theorem with this right triangle ACP. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here by PT is a relation for Pythagoras theorem. So actually, this is the right triangle ACP that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle ACP, AP squared, that is the square of the hypotenuse, equals to AC squared plus CP squared. So I write it down. AP squared, that is the square of the hypotenuse, equals to AC squared plus CP squared. AP is 5, therefore AP squared is 5 squared, that is 25, and it is equals to AC squared. AC is the missing side, so we leave it as it is, plus CP squared. CP is 4, therefore CP squared is 4 squared, that is 16. So we can found out that 25 equals to AC squared plus 16. Here we subtract 16 from this equation, and finally we get that AC squared equals to 25 from 16 is 9. Here we take a root out of this equation, and finally we get that AC equals to the square root of 9, that is 3. So AC equals to 3 units in its length. This is side AC that is equal to 3 units in its length. So here, this is side AC that is equal to 3 units in its length. Side AC equals to 3 units in its length. we know that BP is a straight line. So if you focus on the upper side of the straight line BP at point C, here the sum of the angles must be equal to 180 degrees, according to rule 3, that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line BP at point C? We have this angle that is right angle plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. According to rule 3, of course. In the next step, we define the center of this circle. This point is point O. And we'll join points O and B together by a straight line. We will define the radius of this circle as x. So what is the definition of line segment OB? Line segment OB starts from point O, that is the center of the circle, and then at point B, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OB is the radius of the circle that is equals to x according to our definition. So here you can implement rule 1 because we have the radius OB that is drawn to point B, that is the point of tendency of tangent PB with this circle. And whenever your radius is drawn to the point of tendency, then tangent PB will be perpendicular to the radius BO. If PB is perpendicular to BO, it means that this angle equals to 90 degrees according to rule 1. In the next step, we'll do a construction, that is to say, from this point O, that is the center of the circle, we'll go perpendicular on AC. Again, from point O, we'll go perpendicular on AC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point O and AC. This point is point E. So actually, by doing this construction, we get the quadrilateral OECB. Inside quadrilateral OECB, we have 1, 2, 3 rectangles. The sum of 3 rectangles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral OEBC, we have 4 rectangles. And according to rule 5, any quadrilateral that has 4 rectangles must be this rectangle, not a square. So we relate to quadrilateral OEBC is a rectangle because it has 4 rectangles. So write it down. Quadrilateral OEBC is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So an rectangle OECB side OB must be equal to the opposite side EC, but OB is x, therefore EC must also equal to x units in its length. Likewise, according to the same rule, in the same rectangle OECB, side BC must be equal to the opposite side OE, but BC is 1, therefore OE must be also equal to 1 unit in its length. What is the length of this line segment? Line segment AE. According to the one, from the drawing, it is very easy to see that AE equals to AC minus EC. Again, AC minus EC equals to AE. So I write it down. AE equals to AC minus EC. So AE equals to AC. AC is 3. Minus EC. EC is x. So in total we found out that A equals to 3 minus x units in its length. AE equals to 3 minus x units in its length. In the next step, we join points O and A together by straight line. What is the definition? What is the definition of line segment OA? Line segment OA starts from point O, that is the center of the circle, and ends at point A, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OA is the radius of the circle that is equal to x according to our definition. So in the next step, I copy the right green triangle AOE in a new page, and we implement the Pythagoras theorem on this right green triangle AOE. Here by PT is a motion for Pythagoras theorem. So actually, this is the right green triangle AOE that is going from the original drawing according to the Pythagoras theorem. In this right triangle AOE, AO squared, that is the square of the hypotenuse, equals to AE squared plus OE squared. So I write it down. AO squared, that is the square of the hypotenuse, equals to AE squared plus OE squared. AO is x, therefore AO squared is x squared, and it is equals to AE squared. A is 3 minus x, therefore AE squared is 3 minus x squared, plus OE squared. OE is 1, therefore OE squared is 1 squared, that is 1. So in conclusion, we found out that x squared equals to 3 minus x squared plus 1. Here we open the brackets on this side of the equation, and finally we get that x squared equals to 3 minus x squared. 3 minus x squared equals to 3 squared, that is 9, plus x squared, minus 2 times 3 times x, that is minus 6x, plus 1. So here we have x squared on both sides of the equation, so x squared gets cancelled. After cancelling x squared on this side of the equation, we have nothing, that is to say 0, equals to 9 plus 1 is 10, minus 6x. So we found out that 0 equals to 10 minus 6x. Here we add 6x to this equation, and finally we get that (6x) equals to 10. Here we divide this equation by 2 and get that 6x over 2 is 3x, equals to 10 over 2 is 5. So 3x equals to 5, and we divide this equation by 3, and finally we get that x equals to 5 over 3 units in its length. So we found out that the radius of this circle, x equals to 5 over 3 units. Our mission is to find out the area of this circle. What is the area of this circle? Actually, the area of any circle equals to pi times the radius of the circle squared. So it is pi, and the radius of this circle is x, therefore the radius squared is x squared. So in total, we found out that the area of this circle, that is the area that we are looking for in this question, is equals to pi x squared. So it is pi, x is 5 over 3, therefore x squared is 5 over 3 squared. So in total, the area of the circle equals to, here we have pi times 5 over 3 squared. 5 over 3 squared equals to 5 squared, that is 25, over 3 squared, that is 9. So in total, we found out that the area of the circle equals to either 25 pi or 9 square units. So in terms of numbers, it is equals to 8.727 square units. Repeat again, actually found out that the area of this circle, that is the area that we're looking for in this question, it is equals to either 25 pi over 9 square units, so in terms of numbers, the area of this circle equals to 8.727 square units. We finish with the first question. So in the next step, I present you the second question, and we will answer the second question. Our mission in the second question is to find out the area of this trapezoid ABCD. Repeat again. Our mission in the second question is to find out the area of this trapezoid ABCD. We know that side AB equals to 16 units, side AD equals to 17 units, side BC equals to 25 units, and side DC of this trapezoid ABCD equals to 45 units in its length. Again, our mission is to find out the area of this trapezoid ABCD. First of all, we know that the area of any trapezoid is equals to the sum of its two parallel bases. In this case, it is AB plus DC times the height. The height H must create 90 degrees with the two parallel sides, that is to say with AB and DC, divided by 2. So, if we found out that the area of a trapezoid, it is equals to the sum of its two parallel bases, that is to say it is AB plus DC. Times the height. We define the height as h. This is the relation for the height, h, divided by 2. Repeat again. The area of trapezoid ABCD will be equal to the sum of its two parallel bases, that is to say AB plus DC times the height divided by 2. Again, the height must create 90 degrees with the two parallel bases, that is to say with AB and DC. So in the first step, we will do a construction, that is to say, from point A, we will go perpendicular on DC. Again, from point A, we will go perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point A in DC. This point is point E. By doing this construction, we created the right triangle, triangle AED. We'll define side A of this triangle AED as H. H is the height of trapezoid ABCD. Why H is the height? Because the height, the H, A is equals to X, create 90 degrees with the base DC. Therefore, the height of trapezoid ABCD is equals to H. Okay, we define the length of this side DE as X. In the next step, I'll copy the right triangle AED in a new page and implement the Pythagoras theorem with this right triangle, triangle AED. Here by PT is the version for Pythagoras theorem. So actually, this is the right triangle AD that is coming from the original drawing. According to the Pythagoras theorem, in this right triangle AD squared, that is the square of the hypotenuse, equals to AE squared plus ED squared. So write it down. So actually, AD squared, that is the square of the hypotenuse, equals to AE squared plus ED squared, according to the Pythagoras theorem. AD is 17, therefore AD squared is 17 squared, that is 289, and it is equals to AE squared. AE is h, therefore AE squared is h squared, plus ED squared. ED is x, therefore ED squared is x squared. So in conclusion, we found out that according to equation 1, 289 equals to h squared plus x squared. In the next step, we will do another construction, that is to say, from point B, we will draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC. This point is point F. So we know that in trapezoid ABCD, side AB is parallel to side DC. And here we have line segment BF that cuts the two parallel lines AB and DC. Those two angles are defined as one-sided interior angles. And according to rule 16, the sum of two one-sided and interior angles is equal to 180 degrees. So I put again on rule 16. According to rule 16, the sum of one-sided interior angles is equal to 180 degrees. So here we have line A is parallel to line B, and this is line I that cuts the two parallel lines A and B. So here, according to rule 16, the sum of those two angles that are defined as interior and one-sided angles is equal to 180 degrees. That is to say, 3 plus x equals to 180 degrees. 3 plus 6 equals to 180 degrees. And those two angles also defined as one-sided interior angles. So angle 4 plus 5 also equals to 180 degrees in its size. Actually, all the angles that are located between the straight line A and B are defined as interior angles. Those angles are 4, 5, 4, 3, 5 and 6. And what is one-sided angles? Relate to line I. All those angles are located on the right side of the straight line I, and therefore they are all defined as one-sided angles. And all those two angles, that is to say the angles 2, 3, 5 and 7, they are all defined also as one-sided because they are located on the left side of the straight line I. So the angles that are both one-sided and also interior angles are the angles 3 and 6. According to this rule, rule 16, angle 3 plus angle 6 equals to 180 degrees in its size, and those two angles are also defined simultaneously as one-sided and interior angles. So, according to rule 16, the sum of those two angles, that is to say, angle 4 plus 5 equals to also to 180 degrees. So, according to rule 16, we get that the sum of those two angles that are defined as one-sided and also interior angles, in total they must be equal to 180 degrees. So this angle equals to 90 degrees in size, and this angle in total they must be equal to 180 degrees according to rule 16. Therefore this missing angle must be equal to 90 degrees in its size. In order to complete the sum of those two angles to 180 degrees, this missing angle must be equal to 90 degrees in its size. Likewise, according to rule 16, those two angles that are defined as one-sided and interior angles, they must be equal to 180 degrees. So this angle equals to 90 degrees. Therefore, the missing angle must be also equal to 90 degrees. In order to complete the sum of the angles, the sum of those two angles, the sum of those two angles will be equal to 180 degrees. This angle must be equal to 90 degrees in its size. According to rule 16, of course. So, actually we found out that in quadrilateral ABFE, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be a rectangle if not a square. So, related to quadrilateral ABFE, it's a rectangle because it has 4 right angles. So, I write it down. This is quadrilateral ABFE, and it is a rectangle according to rule 5 because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABEF, side AB must be equal to the opposite side EF. But AB is 16, therefore EF must be also equal to 16 units in its length. Likewise, according to the same rule, in the same rectangle ABEF, side AE must be equal to the opposite side BF. But AE is H, therefore BF must be also equal to H. So in the next step, I'll copy the right triangle BFC in a new page, and we will implement the Pythagoras theorem of this right triangle BFC. Here by PT is the abbreviation for Pythagoras theorem. But what is the length of right segment FC? From the drawing it is very easy to see that FC equals to DC minus DE minus EF. Again, FC total equals to DC minus DE minus EF. So I write it down. FC equals to DC minus DE minus EF. So in total we found out that FC equals to DC. DC is 44 minus DE. DE is X according to our definition minus EF. We found out that EF equals to 16 units in its length. So in total we found out that FC equals to 44 minus 16 is 28 minus X. So FC equals to 28 minus X units in its length. This is side FC, this is equals to 28 minus X units in its length. So okay, this is the right triangle BFC that is according to the original drawing, according to the Pythagoras drawing, in this right triangle BFC. BC square equals to BF square plus FC square. So I write it down. So BC square, that is the square of the hypotenuse, equals to BF square plus FC square. The hypotenuse BC equals to 25 units in its length, therefore BC square is 25 square, that is 625, and it is equals to BF square. BF is h, therefore BF square is h square plus FC square. FC is 28 minus x, therefore FC square is 28 minus x square. So we found out that 625 equals to h square plus 28 minus x square. Here we open the brackets on this side of the equation, and finally we get that 625 equals to h square plus 28 minus x square equals to 28. It is actually 28 minus x square equals to 28 square, that is actually equals to 784 plus x square minus 2 times 28 times x is minus 56x. So we found out that 625 equals to h square plus 784 plus x square minus 56x. Here we'll subtract 625 from this equation. So here we left with nothing, that is to say 0, equals to h square plus x square minus 56x, 784 minus 625 equals to 159. So we found out that h square plus x square minus 56x plus 159 equals to 0. We have already found out that according to equation 1, h square plus x square equals to 289. Therefore, we can substitute x square plus x square in this equation, equation 2 by 289. We do it now, we get that 0 equals to h square plus x square according to equation 1 is 289 plus 159 minus 56. So we found out that according to equation 2, 0 equals to 289 plus 159 equals to 448 minus 56x. In conclusion, we found out that 0 equals to 448 minus 56x. Here we add 56x to this equation, equation 2, and finally we get that according to this equation, equation 2, (56x) equals to 448. Okay, again, we found out that 56x equals to 448. So here we divide this equation 2 by 56. And finally we get that according to this equation 2, x equals to 448 over 56 equals to 8. We found out that x, that is the radius, that x, that is the length of this line segment DE is equals to 8 units. But according to equation 1, we have already found out that x squared plus h squared equals to 289. Now we know if x is 8, it means that x squared must be equal to h squared, that is 64. Therefore, we can substitute x squared in this equation 1 by 64. We'll do it now. We get that x squared is 64 plus h squared equals to 289. Here we subtract 64 from this equation and finally get that h squared equals to 289 minus 64 is 225. So if you found out that according to equation 1, h squared equals to 225. Here we take a root out of this equation and finally we get that h, that is the height of trapezoid ABCD, equals to the square root of 225, that is 15. So the height of trapezoid ABCD, height h, equals to 15. The area of trapezoid ABCD is equals to the sum of its two parallel bases, that is actually AB plus DC, times the height, that is h, divided by 2. And again, the area of trapezoid ABCD equals to the sum of its two bases, that is the sum of its two parallel bases, that is actually AB plus DC, times the height, that is h, over 2. So in total, the area of trapezoid ABCD is equals to AB is 16 plus DC is 44 multiplied by the height h, h is 15 over 2. So in total, we found out that the area of trapezoid ABCD is equals to 16 plus 44 is 60, and 60 over 2 is 30. So it is actually 30 times 15. 30 times 15 is 450 square units. Repeat again, actually found out that the area of this trapezoid ABCD is equals to 450 square units. We finished with the second question. So in the next step, I'll summarize the lecture. We start with the first question, of course. Our mission in the first question was to find out the area of this circle. So in the drawing we have a circle and we have also the right triangle ACP that cuts the circle at 2 points, A and this point. In addition, you know that the side CP of the right triangle ACP equals to 4 units in its length, 97 CB equals to 1 unit in its length. This is again ACP, that is the right angle. Again, our mission is to find out the area of this circle. So first of all, we can implement the rule 2. Well, because if we focus on this common external point, point P, from this common external point P, we have two tangents to this circle. Tangent PB and tangent PA. It is given us the question that PA and PB, they are tangents to the circle. So we have two tangents from the common external point P. Tangent PA and tangent PB. And according to rule 2, they are equal to each other. That is to say, PA equals to PB according to rule 2. Repeat again. According to rule 2, the length of tangent PA is equals to the length of tangent PB. PA equals to PB according to rule 2. But we know that PB equals to 4 plus 1, that is 5. So we can write here that PB equals to 5, and from this equation PA equals to PB equals to 5, we will derive that PA also equals to 5 units in its length. Okay, this is side PA, this is equals to 5 units in its length. In the next step, we copy the right triangle ACP in a new page and we implemented the Pythagoras theorem of this right triangle, triangle ACP. Actually, this is the right triangle ACP that is coming from the original domain according to the Pythagoras theorem. In any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle ACP is AP, therefore the square of the hypotenuse is AP square, and AP square equals to AC square plus CP square. AP is 5, therefore AP square is 5 square, that is 25. And it is equals to AC square. AC is the missing side, so we leave it as it is. Plus CP square. CP is 4, therefore CP square is 4 square, that is 16. So in total, we found out that 25 equals to AC square plus 16. Here, we subtract 16 from this equation, and finally found out that AC square equals to 25 from 16 is 9. So AC square equals to 9. Here we took a root out of this equation, and finally found out that the missing side AC equals to the square root of 9, that is 3. AC equals to 3 units in its length. Okay. This is side AC that is equals to 3 units in its length. In the next step, we define the center of this circle, this point O. We also define the radius of this circle as x. In the next step, we join points O and B together by straight lines. Point O is the center of the circle, point B is the point, and the point on the circle itself, therefore OB is the radius of the circle, that is equals to x according to our definition. Here we can implement rule 1, because according to rule 1 we have the radius OB that is equal to x, the radius OB is drawn to point B, that is the point of tendency of tangent PB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent PB will be perpendicular to the radius BO. If PB is perpendicular to BO, it means that this circle equals to 90 degrees according to rule 1. Here we know that PB is tangent to this circle. So PB is a tangent, it is absolutely a straight line. So PB is the straight line. If we focus on the upper side of this straight line PB at point C, here the sum of the angles must be equal to 180 degrees according to rule 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of PB at point C? We have this angle that is a right angle plus this missing angle. In total they must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. In the next step we did the construction, that is to say from this the center of this angle, that is to say from this point O, we draw perpendicular on AC. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC. This point is point E. By doing this construction, we write the quadrilateral OECB. Inside quadrilateral OECB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral OECB, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be in this rectangle flat and square. So we relate to quadrilateral OECB is rectangle because it has 4 right angles. But we also know that the opposite sides of the rectangle are equal to each other. So rectangle OECB, side OE must be equal to the opposite side CB. But CB is 1, therefore OE must be also equal to 1. Likewise, according to the same rule, in the same rectangle OECB, side OB must be equal to the opposite side EC. But OB is x, therefore EC must be also equal to x units in its length. What is the length of 970 AE? From the drawing, it is very easy to see that AE equals to AC minus EC. Again, AC minus EC equals to AE. Here, A equals to AC minus EC. So A equals to AC, that is 3, minus AC, that is x. So in total, A equals to 3 minus x units in its length. In the next step, we join points O and A together by straight line. What is the definition of line segment OA? Line segment OA starts from point O, that is the center of the circle, and then at point A, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OA is the radius of the circle that is equal to x according to our definition. So in the next step, I cover the right green triangle OAE in a new page, and we implemented the Pythagoras theorem of this right green triangle OAE. Okay, this is the right triangle OAE that is according to the original drawing. According to the Pythagoras theorem, this right triangle AOE, AO squared, that is the square of the hypotenuse, equals to AE squared plus OE squared. Again, AO squared equals to AE squared plus OE squared. The hypotenuse AO is x, therefore AO squared is x squared, and it is equals to AE squared. AE is 3 minus x, therefore AE squared is 3 minus x squared, plus OE squared. OE is 1, therefore OE squared is 1 squared, that is 1. So in total, we shall find out that x squared equals to 3 minus x squared plus 1. Here we open the brackets on this side of the equation. We found out actually that x squared equals to 3 minus x squared. 3 minus x squared equals to 3 squared, that is 9, plus x squared, minus 2 times 3 times x, that is minus 6x plus 1. Here we have x squared on both sides of the equation, so x squared will get cancelled, cancel the x squared, and this side of the equation we will left with nothing, that is to say 0. In the other side of the equation we have 9 plus 1, that is 10, minus 6x. So in total we should find out that 0 equals to minus 6x. So here we added 6x to this equation, and finally found out that 6x equals to 10. Here we divided this equation by 2 and finally found out that 6x over 2 is 3x and 10 over 2 is 5. So in total we should find out that 3x equals to 5. Here we divided this equation by 3 and finally found out that x equals to 5 over 3 units in its length. That is to say, the radius of this circle x equals to 5 over 3 units in its length. Our mission is to find out the area of this circle. The area of any circle equals to the pi times the radius of the circle squared. Again, the area of any circle equals to pi times the radius of the circle squared. The radius of our circle is x. Therefore, the radius squared is x squared. So, therefore, the area of our circle will be equal to pi x squared. So it is pi times x squared. X is 5 over 3. Therefore, x squared is 5 over 3 squared. So in total, we should find out that the area of our circle equals to pi times 5 over 3 squared. So it is pi, and 5 over 3 squared equals to 5 squared, that is 25, over 3 squared, that is 9. So in total, if you found out the area of this circle equals to either 25 pi over 9 square units, so in terms of numbers, the area of this circle equals to 8.727 square units. So we finish with the first question. The next time I actually presented to you the second question, and then we solve the second question of this lecture. Our mission in the second question is to find out the area of trapezoid ABCD. So if you know that the area of any trapezoid equals to the sum of its two parallel bases, in this case it is AB plus DC times the height over 2. The height must create 90 degrees with the two other bases that are parallel to each other. So if it again, the area trapezoid ABCD will be equal to AB plus DC, that is the sum of its two parallel bases times the height over 2. Again, the area of trapezoid ABCD will be equal to the sum of its two parallel bases, that is actually AB plus DC times the height h over 2. Again, the height h must create 90 degrees with the two other parallel bases. That is to say, AB and DC. In the next step, we did a construction, that is to say, from this point A, we draw perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A in DC. This point is point E. In the next step, we define the length of side AE is h, and the length of this line 7D is x. By doing this construction, we created the right triangle AED. So I copied the right triangle AED in a new page and we implemented the Pythagorean theorem on this right triangle AED. So actually, this is the right triangle AED that I copied from the original drawing. According to the Pythagorean theorem, in this right triangle AED, AD squared, that is the square of the hypotenuse, equals to AE squared plus ED squared. Repeat again, AD squared equals to AE squared plus ED squared. AD is 17, therefore AD squared is 17 squared, that is 289, it is equals to AE squared. A is h, therefore A squared is h squared, plus ED squared. ED is x, therefore ED squared is x squared. So in total, if we found out that 289 equals to h squared plus x squared. This is according to equation 1. In the next step, we did another construction, that is to say, from this point B, we do perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B in DC. This point is point F. So here we can implement rule 16. According to rule 16, the sum of two one-sided interior angles is equal to 180 degrees. Those two angles, they are located between the parallel lines AB and DC, and for that reason they are defined as interior angles. Those two angles also located on the same side of the straight line AE. Those two angles are actually located on the right side of the straight line AE, and therefore they are also defined as one-sided. So those two angles are both one-sided, and also the interior angles. And according to rule 16, the sum of two interior angles that are also one-sided angle, like in this drawing, the sum of those two angles will be equal to 180 degrees. So the sum of those two angles must be equal to 180 degrees according to rule 16. But this angle equals to 90 degrees according to our construction. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of those two angles to 180 degrees, this missing angle must be equal to 90 degrees in its size. Likewise, those two angles, they are also defined as interior angles and one-sided angles, because they are both located between the parallel lines AB and DC. For this reason, they are interior angles, and they are both located on the right side of the straight line BF, and therefore they're also defined as one-sided. So those two angles that are also two angles and one-sided angles simultaneously, the sum of those two angles, according to rule 16, the sum of those two angles must be equal to 180 degrees. But this angle equals to 90 degrees according to our construction. And therefore this missing angle must be also equal to 90 degrees in size. In order to complete the sum of those two angles to 180 degrees, the missing angle must be equal to the sum of the missing angle must be equal to 90 degrees. So actually found out that in quadrilateral ABFE we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle if not a square. So we relate to quadrilateral ABFE is rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So a rectangle ABFE, side AB must be equal to the opposite side FE. But AB is 16, therefore FE must be also equal to 16 units in its length. Likewise, according to the same rule, in the same rectangle ABFE, side AE must be equal to the opposite side BF. But AE equals to H, therefore BF must be also equal to H. Okay, so what is the length of line segment FC? From the drawing it is very easy to see that FC equals to DC minus DE minus EF. Again, FC in total equals to DC minus DE minus EF. Repeat again, FC equals to DC minus DA minus EF. So FC equals to DC. DC is 44, according to what is given as the equation, minus DE. DE is X according to our definition, minus FE. We already found out that FE equals to 16. So in total, FC equals to 44 minus X minus 16. 44 minus 16 is 28. So in total, this is the equation, we have 28 minus X. So FC in total equals to 28 minus X. So in the next step, I copied the right triangle BFC in a new page and we implemented the Pythagoras theorem on this right triangle BFC. So actually, this is the right triangle BFC that I copied from the original drawing according to the Pythagoras theorem in this right triangle BFC. BC squared, that is the square of the hypotenuse, equals to BF squared plus FC squared. BC is 25, therefore BC squared is 25 squared, that is 625, and it is equal to BF squared. BF is 8, therefore BF squared is 8 squared, plus FC squared. FC is 28 minus X, therefore FC squared is 28 minus X squared. So in total we found out that 625 equals to H squared plus 28 minus X squared. Here we open the brackets on this side of the equation and finally found out that 625 equals to H squared plus 28 minus X squared. 28 minus X squared equals to 28 squared, that is 784, plus X squared minus 2 times 28 minus X is minus 56X. So in total we found out that 625 equals to H squared plus 784 plus X squared minus 56X. Here we subtracted 625 from this equation, so in this side of the equation we left with nothing, that is to say 0. And it is equals to H squared plus X squared, and 784 minus 625 equals to 159. So in total we found out that 0 equals to H squared plus X squared minus 56X plus 389. But according to equation 1, we have only found out that H squared plus X squared equals to 289. Therefore we can substitute H squared plus X squared in this equation 2 by 289. We did it and we found out that according to this equation 2, 0 equals to X squared plus X squared, that is 289 according to equation 1, minus 56X plus 159. So 0 equals to 289 plus 159. 289 plus 159 equals to 448. So in total we found out that according to equation 2, 0 equals to 448 minus 56X. Here we added 56X to this equation 2, and finally found out that according to equation 2, 56X equals to 448. Here we divided this equation 2 by 56, and finally found out that according to this equation 2, X equals to 448 over 56, that is 8. So X equals to 8 units in its length. But according to equation 1, we know that X squared plus H squared equals to 289. If X is 8, X squared must be equal to X squared, that is 64. So we can substitute x squared by 64 in this equation in question 1. We did it and found out that actually x squared is 64 plus h squared equals to 289. Here we subtracted 64 from this equation and finally found out that according to this equation 1, h squared equals to 289 minus 64 is 225. So according to equation 1, we actually found out that h squared equals to 225. Here we took a root out of this equation and finally found out that the height edge of trapezoid ABCD equals to the square root of 225, that is 15. So she found out that edge, that is the height of this trapezoid ABCD, equals to 15 units in its length. Our mission is to find out the area of this trapezoid ABCD. The area of trapezoid ABCD will be equal to the sum of its two parallel bases, that is to say AB plus DC, times the height over 2. Okay, again, the area of trapezoid ABCD equals to the sum of its two parallel bases, that is actually AB plus DC, times the height, that is edge, over 2. So the area of trapezoid ABCD equals to AB, that is 16, plus DC, that is 44, times the height edge, that is 15, divided by 2. So in total, the area of trapezoid ABCD equals to 16 plus 44, that is 60. 60 over 2 is 30. So in total, the area of trapezoid ABCD equals to 30 times 15, that is 450 square units. Okay, again, I should found out the area of this trapezoid ABCD equals to 450 square units. Okay, thank you very much.